on time, but that's good. We'll have time for more questions. So next up, we have Danny Reisman from Peak Web Consulting giving a talk about RSTP to MSTP spanning tree migration in a live data center.
Morning, everybody. Wow, we're super early. It's nice. But everybody made it, which is really good. Hi, my name is Donnie Roisman, and I work with Peak Web Consulting. I've been doing this for about 4 years. We do basically contract work for network engineering contract work, so folks that need additional staff or need more sophisticated staff or need a second pair of eyes and don't have it in-house, they can call us up. And what's been nice about this, I've been able to see a lot of really interesting network environments. I've been able to come into a lot of existing operational environments and find places where people have done things differently than I've done in my previous organizations. Find places where, find lots of cool mistakes that we get to fix or we get to talk about. A lot more than just if you're working in one enterprise for a while, which is what I was doing before this. So this talk about, we found ourselves in a situation on a network we were charged with running where we had to migrate from a per VLAN rapid spanning tree to multiple spanning tree because of some high utilization in the network core. So our primary challenge was migrating with minimal impact to a live production network. We had lots of customers, lots of bits flowing, and we didn't want to do a major hit since this was pretty much data center wide. Our secondary challenges were to define some best practices for MST that gave us really good stability, really good future flexibility, and all at the same time, we had really limited reference material that we could find online, folks we spoke to. Not a lot of people have been deploying MST, at least that I had access to. And we didn't have a lot of experience, and really I'm saying a lot of previous failures. We all get to use our failures to build best case practices. We usually don't just deploy something once and say, hey, we did it right. And I really enjoy having a bag full of failures that I take along with me to new jobs, because I can say, here's all the ways that we've tried it, that it doesn't work. So I feel really confident about doing it this way because I know it'll work really, really well. So what this isn't about, I'm not going to get into the nitty-gritty of RSTP, MST, state machine, topology change notifications, CST, IST, CIST. I really got to be honest with you. I read so much about this. I read the vendor docs, I read the white papers, I read the specs. I got lost in the details. Some of the stuff I don't even exactly understand, and I probably wasted a couple days trying to understand all the terminology before I just really jumped in and got my hand dirty. But if you're interested, check the vendor docs, check the white papers. You can read all about it. You can maybe get as confused as I am and say, you know what, I'm just going to type the statements and see what happens. Who's going to be interested in the statement? If you run data centers with a large number of VLANs, if you have layer 2 connectivity to top of your rack switches, if you're having scaling issues with a large number of spanning tree instances, if you're running some vendor equipment that runs in default in a mode that needs to be adapted as the network grows to a significant scale. Let me tell you a little bit about our environment. This is really a sample of the real environment. Obviously, I can't show you the exact environment. This is pretty good representation. Excuse me. I'm not spreading this around, I promise. I am actually on the healthy side of sick. Last week I was on the sick side of sick. So we had a managed hosting facility. We needed flexibility of putting any VLAN to any server and any rack throughout the data center. Every customer has their own dedicated VLAN and their own subnet. We had layer 2 switches in the racks, uplinking to layer 3 collapsed distribution core switches. We didn't have fault tolerance and no single point of failure, so therefore running spanning tree, 2 uplinks to every rack switch. We had in this environment over 200 customers in the data center, so we had over 200 live VLANs. So the way the network works, you've all seen this before. A couple layer 3 cores, that actually looks okay. A couple layer 3 cores up here, and a whole bunch of rack, 1, 2, 3, rack number N, and dual uplink, everybody blocking towards core switch 2. That way we can guarantee 100% capacity. If core switch 1 or an uplink were to fail, we know there's 100% availability on the redundant link. The problem we saw was we had a high number of spanning tree, what Cisco calls logical port instances. We were running Cisco's here, and their default is per VLAN spanning tree. In this case, it was RSTP, so it's called rapid PVST in the config. What you do is you multiply the number of VLANs by the number of interfaces that are actually live, and you get a number of logical port instances. And we were in the, I think we were about 6,000 on the switch, or sorry, we were 8,000 on the switch. The recommendation was not to exceed 6,000, and every time you added a new port or VLAN, you got a little syslog message saying you exceeded the recommended maximum. What we ended up with was we had too many spanning tree instances for the layer 3 core switch. There are concerns of CPU utilization, keeping track of all those BPDUs, memory utilization, keeping track of all the spanning tree state machines, convergence when links come up. If you spend too much CPU cycles and you start flapping all sorts of other real-time protocols, HSRP, maybe OSPF if your timers are set really low, maybe BFD if you're doing centralized forwarding. So resource exhaustion at the core. Just want to take a moment and talk about per VLAN spanning tree. So Cisco per VLAN spanning tree is the default. I haven't found a way to actually switch to single instance spanning tree. And I apologize, I realized too late I actually put Foundry here, and I know we're supposed to say Brocade. So with Brocade IP switches, which used to be Foundries, they offer a per VLAN mode, which interoperates really, really well with Cisco. The Juniper MXs and EXs in the newer code, they have something they call VSTP, which interoperates with Cisco, reportedly really well. I haven't had an opportunity in large scale to do this. Force 10, the FTOS, and the newer SFTOS, if running S-Series, they offer a PVST Plus, which I just learned this morning automagically discovers 802.1D versus 802.1W, so legacy spanning tree, rapid spanning tree interoperates. So lots of vendors will run in this mode. Cisco is the one which really it kind of inspired this talk because it runs by default in this mode, and when you scale, you start having some problems. So looking back, we're talking about this internally when we spent so much time on this project. Like, are we too spoiled with per VLAN spanning tree? Cisco is really nice that way, and some of us really grew up on Cisco switches, and we thought this was the right way to do it. But do we really need it in a data center environment? In data center environment, it's really simple. You have a whole bunch of inverse triangles or V-shaped networks where we don't want to use the alternate path during steady state. We want 100% on link 1 and 100% backup on link 2. In some metro environments or in legacy time when we actually had resource limitations on the links, we would make large rings and we would send some VLANs this way and some VLANs that way, and that was great. But in the data center environment, we really don't need it. We just need layer 2 redundant path, one uplink passing, one uplink blocking, and some kind of rapid failover if there's an outage of some kind, or to allow for easy maintenances. So as our options, so our simplest solution is just to collapse from a per VLAN to a single instance spanning tree. But since we're running Cisco, the only way to reduce the number of logical port instances was to migrate to MST, 802.1s multiple spanning tree. Ironically, it was called multiple spanning tree, but in our environment, we're trying to create a single spanning tree using multiple spanning trees. It was kind of hard to convince the client, the customer of ours, that this was the right way to go because of the terminology. So here's the solution design that we came up with. So MST allows you pretty much to map multiple VLANs into a single instance. 802.1s is a standard, allows really good vendor interoperability for multiple spanning trees where some vendors were doing single instances. Typical use in a non-Cisco environment is you're doing load sharing, you're sending some VLANs live here and some VLANs live there in a ring, VLANs in multiple different directions. Now the driver for using this on Cisco equipment, because Cisco already has this wonderful per VLAN, well, you need to reduce the number of instances. What are the problems with MST? So there's a new configuration complexity. All switches within one region, which in our environment is typically one data center is one region, or it may be a slice of data center if you have a very large environment. They have to have the same exact VLAN to MST mapping on every single layer 2 switch participating in the region in order for this to work. So it means that anytime you make a VLAN or an MST mapping change, you have to update every single switch in that environment. There's an issue with change control. For example, if you're adding a new app layer VLAN, a database or middleware VLAN, now you need to update all of your web server racks with the new mapping if it's joined onto a new instance, or if it's joined to an existing instance that wasn't previously pre-generated. And if you have a very strict change control environment, you're going to have to justify why are we touching web server racks when all we're doing is adding an app server VLAN. So that might impact you in your environment. Some of the design ideas we considered while trying to build this up: should we just go ahead and just make a single instance, put 4,000 VLANs in it, and we're done? We're back to single instance spanning tree like we've been doing years before or on other vendor platforms. Or should we pre-create some instances? So we can be a little bit smarter and anticipate, okay, we'll make an instance number 1 and put 100 VLANs, instance number 100, put the next 100 VLANs, and 200, put the next 200 VLANs, and kind of get the whole VLAN bucket covered that way. And then we look back and said, hold on, do all vendor equipments actually support us using these arbitrary numbers? Can we do instance 100, 200, 300? No, it turns out no. Some of the vendors, you could just, if they support 16 instances, you can just number 1 through 16, and that's it. So if you went ahead and you pre-created instance 100, and then you bought something from switch router Z, you're going to actually have a problem. You're going to have to renumber all those other instances, which is going to be kind of a pain. Our migration challenges: we had this live production network, as I said, and we're trying to do a cutover with near zero downtime. We brought up a lab, we kind of simulated it, and we couldn't find a way with zero downtime. We found plenty of ways to melt the network if you do it wrong. We had all sorts of fun stuff going on that we didn't anticipate. So you can actually really kill yourself, which was kind of cool. And in the end, we found a way to do a migration live environment with just a single 45-second hit, which is pretty much one cycle of the blocking, learning, forwarding using default timers. I personally don't tweak spanning tree timers. If you guys are more ballsy than I am, you can actually reduce this if you tweak your timers. Here's our lab, really simple. We just put a couple 3560 Gs as our layer 3 core simulation. And we put 3 2960 Gs as our rack switches, 2960 G as our rack switches, and we put up a couple servers just so we could do some continuous pings and measure really how significant the network impact was. Well, a couple key things that we learned from our lab was know your routes. So set your cores to root and secondary root. You set it to the highest STP priority. This is the lowest numeric priority value. Set it consistent for all VLANs. Set the priority of your rack switches to actually be lower than default, so that if you do miss a VLAN or MST instance, you don't accidentally have a rack switch as your root. This can cause weird things and weird loops and unanticipated results. Start your work from your roots and kind of work your way down towards the rack switches. Interesting to remember that MSTP actually runs RSTP BPDUs for backwards compatibility, so it makes the migration a lot less painful if you're already running 82.1W RSTP in your network. And choose your VLAN to instance mapping carefully. Try to be smart about what you choose in advance, because it is kind of painful to change in the future. Some gotchas that we found, as I mentioned before: some devices you can arbitrarily number instances. You can have instance 100, instance 700, instance 3000. Some devices only support, if they have 16 instances, they'll only support numerically valued 1 through 16 or 1 through 32. And of course, the MST does have to match on all devices. That's the region name, revision number, and the VLAN to instance mapping for all VLANs. Even if those VLANs don't exist on that switch, he has to know about the instance to VLAN mappings that are used throughout the entire region. MST generates a MD5 checksum value based on these 3 key identifiers and passes that MD5 around, and everyone has to match if they want to play. Here's the migration example on this in a Cisco network and how we actually got it done. So our starting point, all our devices were running per VLAN RSTP 802.1W. Core 1 had a priority of 8192 for all VLANs, so he took root. Core 2 was our secondary root with a priority of 16384 for all VLANs, and our rack switches that were all blocking towards Core 2 with a priority of 4096, a little bit worse than default for all VLANs. This is the way it looked at steady state. You saw this before. 2 core switches, everyone blocking towards core switch 2. And this is the walkthrough. So the first thing we did, again, I'm really being Cisco focused, is where I spent most of the time on this project. What's nice about the way Cisco implemented this is you can actually pre-config all of the devices and with the spanning tree mappings and not kick them live until you're all ready with one single config. So you go into spanning tree MST configuration, you create a region name. This is Datacenter 1 MST. You give it a revision number. I'm not going to get into the details of revision number, but just know they all have to match. We started with revision 1. And we decided to pre-create 8 instances where we mapped a couple small groups of VLANs where we use for infrastructure, device to device. And instance number 2, VLANs 5399, we actually weren't using at all, but we pre-created them thinking maybe sometime in the future we might need to do something creative, so we had a block of 50 VLANs there. Instance number 3, 4, 5, 7, 8 is where actually we had all of our customers. We have a 2,000 block. We could support up to 2,000 customers in this environment. And on core 1, we went ahead and we said, okay, MST 0 through 8, priority 8192. On core 2, 16384, and all the rack switches 4960. A little note here, you want to not forget about MST 0. MST 0 is used for any VLANs that weren't put into an instance. It's like the default MST instance. So any VLANs that weren't clearly defined, in this case, you notice that we didn't actually use VLAN 1. VLAN 1 happens to hang out on MST 0. The point is, don't forget MST 0. We saw a client who forgot MST 0, and they were really regretful of that later on when they added more rack switches. So going through the migration, step number 1, this is where you take your network hit. You get on core 1, you type the command spanning tree mode MST. At that instant in time, core 1 actually blocks towards pretty much all of his layer 2 ports. Everybody goes into blocking and listening, forwarding. At that point in time, your network is pretty much nice and quiet. No bits are passing where you expect them to pass at that moment in time. Your HSRP may actually flap. Pretty quick recovery. 45 seconds later, you wait patiently, and your network is restored. Everyone's happy, and your NOC guys can go back to surfing YouTube. Step number 2, migration. You go on to core 2, and you say spanning tree mode MST. Core 2 has a brief blocking forwarding cycle. Doesn't seem to impact traffic. Didn't impact on the 2 networks where we did this, 2 data centers where we did this. Everyone's fine. And migration step 3, you get on your rack switches, and you could just do a rolling scripted spanning tree mode MST. Remember that you pre-configured this block in advance and the priorities in advance. So here you're just kicking it live. At this point in time, the rack switches go into an extremely brief blocking forwarding cycle. We had pings going from server to server. We were doing a tenth of a second, so 10 pings per second. We didn't lose a single ping. So I'm not going to tell you it's 0 impact, but it was less of a tenth of a second, so it was negligible in our environment. What does MST mean for ongoing maintenance? Once it's deployed, there are a few things you got to keep in mind. All new devices really should be pre-configured with identical MST parameters before you plug them into the network. Any VLAN to instance mapping changes you make in the future, you want to make on your root first, then you push it to your secondary, and then you push it to your rack switches. You push it everywhere. Don't leave any stragglers. Currently, there isn't any widespread protocol to automatically propagate your MST changes. According to the docs in VTP v3 on Cisco, I believe MST instance mapping is actually propagated. I don't have any devices running code that's VTP v3 capable. I believe there's still there are limits as to which devices can do it. I think we're going to see everything eventually. But that's Cisco only. I looked around on the other vendors. I couldn't find anything that did propagation of MST instance mapping. So this is pretty much a manual or scripted process, and you really want to make sure, excuse me, you want to make sure you have all your devices matched up. So in summary, MST does add some complexity to your configuration, so you really need to stay on your toes. I didn't cover in this talk, but MST is kind of a cool thing if you are trying to do multi-vendor interoperability and you do want to have per VLAN diverse paths in your network. And we only really deployed this solution a few times here at Peak. And I am interested in hearing feedback if anybody else has done this before, has a better suggestion than some of what I've recommended, or has run into other gotchas that maybe I didn't cover that other folks should be aware of, that maybe in a next revision or additional write-up I should cover. And if anybody knows how to configure Cisco Layer 3 switches for a single instance of RSTP, again, I haven't found it, but if anybody knows it, please tell me. And that's pretty much it. Thanks very much. If any of you have little kids, you might recognize Plex. I'm here for a week, so I'm not going to get to see him, although I get to see him every day at home. So I figured I'd throw him up here and say, hey Plex, how you doing?
Leo Bicknell with ISC. I have one comment and one question for you. The comment, I would say, having done several similar deployments, is in all the ones I've been involved with, we've pointed half of the rack switches at one and half at the other core router. And there were sort of 2 schools of thought as to why that was better than having a primary and a backup. The first was, in a core failure, you only had to slosh around half of the traffic, not all of the traffic. Yep. And the second was on the sort of uplink side of those core switches towards the ISPs or whatever you happen to have. It was better to have some amount of traffic because there are certain interface conditions like errors and whatnot that don't occur with no traffic.
Yep.
That you have to put traffic on them. So having some amount of traffic allowed you to monitor that better and detect those quicker rather than detecting them when you already have a failure. The question I have, though, is in all of the situations I've seen where they've run into too many VLANs in a layer 2 instance, the same requirement that you started with has applied. Any device in any rack has to be able to go on any VLAN. And regardless of the technology involved, that reaches a scaling limit, a different one with each technology. So in every instance I've been involved in, we've pushed hard to move to rack switches that are layer 3 routers using IPs that are specific to a rack, but then doing things like virtual IPs routed with a routing protocol, which appears to scale much better. Did you have those discussions with your client? Were they simply unwilling to listen to them, or were those discussions not had? You know, what are people's experiences with the transition from layer 2 technologies to layer 3 technologies as you hit scaling limits?
Yeah, that's a good point. So to your first point, running hot on half of your links, running hot on both sides, 50-50, it's a really good idea, as you said, for a couple reasons. One is having redundancy is a double-edged sword. If you don't always configure the secondary device properly, you don't know that it's not working until the failover happens, then you realize, oh wow, we actually missed the last couple updates. We've gone back and forth on this a few times. It definitely makes more sense to use your whole network to some degree. That way you can be assured that it's there. Because we build but don't run a lot of networks, we have to leave something behind that is pretty easy to run, and that seems to be the easiest way, as everybody knows this is primary, and if any traffic's on the secondary, you have an abnormal condition. Regarding using non-layer 2 environments, the problem is that in a managed hosting environment, the managed hosting customers kind of expect to be on one flat VLAN. That's their expectation. Oh, I have 3 servers and they all need to be in the same subnet and VLAN because I don't want to know how to do routing and deal with loopback interfaces, and then if I'm running certain operating systems, I have to deal with turning off ARP or turning on ARP properly, or virtual instances. And then the managed hosting operator says, well, I want to give my server customers a really simple environment, but at the same time, I can't leave holes in my racks for unpopulated servers. So if you say, well, this subnet belongs to only this rack, well, you have a customer with only 2 servers, but he might buy a 3rd server 2 months from now, and then you have to put him in a rack on the other side of the data center, and you find some way to bridge it across. There is a need to figure out how to do really large-scale managed hosting. There aren't that many people that have the problem, so I don't think anybody's found the right solution. In a perfect world, you're absolutely correct. Running layer 3 to every rack switch buys you tremendous scaling capabilities. It's really a much cleaner way to go. Unfortunately, it's not always optional when the customer base is really expecting, oh, I want my service to be in one flat VLAN, and I want to be able to do things like move IP addresses around from server to server if I need to take down a box for maintenance or those kinds of things.
Hi, Ben Kessler with Zenetra, and we ran into this same issue with an enterprise customer in a brand new deployment, about 40 or so racks, top rack design, where we had 2 layer 2 switches per rack. And we had spanning tree obviously running, but there were no ports blocking. It was all, basically there were no loops by design. We did each cabinet switch, and there were 2 of them per cabinet, but each cabinet switch had a 4 by gig uplink to the A switch or the B switch for the core. And we ran into the same issue, and it melted down the network when you started having some flapping going on with bad SFPs or whatever. And we got the same feedback from the vendor, well, you need to go to layer 3. Like, this is a brand new environment. And the same sort of things applied where, you know, the network is built so that the data center people or the server people can put their servers wherever for space or cooling or power, whatever the conditions may be. And we had the flexibility of having a maintenance window, so we basically roasted the network and rebuilt it. One of the points I wanted to bring up was that when you do VLAN pruning, So for example, there were some, one of our MST instances was for some core or network management VLANs that did not get extended down to the cabinets. And so we pruned those on the trunk links. Well, the edge devices still needed to know about those MST instances, otherwise they would get confused. And so we ended up, one of the effects of that was that we had all these little routes out there, because each of these cabinet switches were islands for those MST instances. They had no knowledge of any of the others. So that was, we were kind of discussing back and forth, well, do we pass them along the trunk even though nothing out there is going to be in there, just so that MST doesn't look goofy, or do we just leave them as these islands? And so that was, again, some of the fun stuff that we had to deal with in the middle of the night.
What did you end up deciding on the
We
pruning?
left them as islands.
Okay.
Just figured that the chance of somebody inadvertently putting traffic down there was less desirable than the oddball of, well, hey, why is this route down here? So that was how we came up with it.
Okay, cool, thanks. Yeah, we found this actually got exacerbated with virtualization. Even though I think it would really make sense if we could all do layer 3 to a virtual server and then route internally to all the individual servers. So many of our applications are built on this group of servers sits in a flat VLAN, and some applications are even doing multicast. You could route multicast, but some are doing kind of fake multicast based on just broadcast discovery, and they're really expecting servers to sit in this flat VLAN. And when you're doing virtualized servers, VMware, Zen, or whatnot, now you actually really need every VLAN to every single physical server port so you can move your VMs around. And so big layer 2 is still out there, and it's still a problem that many folks are facing. More enterprises nowadays are facing. People only have 10, 20 racks in their data center are going to face it because their CTOs and their CFOs are opening up Business Week magazine and reading, oh, virtualization saves you money. And so they say, oh, you need to push virtualization. I just bought $10,000 worth of VMware licenses, so go deploy. So So I say MST is good, just know about it. The thing about pushing it to all the switches, we found you didn't have to tell all the switches about the VLANs themselves, so I don't think you really have to end up with islands there, but you do need to tell them at least about the instance mapping, and that was kind of a hard one to understand. But once we caught it, we need to make sure that everybody else who wants to know about it, please remember to do it. So thank you very much. If you do know people who need assistance, Peak is always available here to help. You can email me here if you have any casual questions. I'm happy to always take a phone call or an IM chat or whatnot to help others in need. And if it turns into a business opportunity, great. But if it helps somebody, that's even better. So thank you very much.